and I don't know how it's going to turn out. It's on these things called otoliths. She went, yes! And so there it started. And so Mimi's going to describe her project, which some of you know about because of the smells wafting out of my lab at periodic moments. And she'll explain why. And it's just very exciting to see all of this come together in it's a project which took a lot of patience looking through a microscope for long hours, making measurements of very small things, but trying to link it to big picture processes. And she's going to tell you all about it. So, and I hope you all stay afterwards for cake and champagne.
I'm going to tell you about South Polar skuas and fish otoliths, and how little tiny fish ear bones can tell you about seabirds, which can tell you about climate change and sea ice in general. So South Polar skuas are predatory seabirds. They live and breed on the Antarctic Peninsula, where they're mainly piscivorous, which means they mainly eat fish. And really, for seabirds in general, it's been pretty well established that their reproductive success is really dependent on food availability. And so this means that they can kind of be used as indicators of marine health, of the marine environment, because especially in areas where, like Antarctica, where there's sea ice and where it's really hard to sample within the water. And so being able to watch these birds that breed on land in really large colonies, they're easy to find, being able to kind of use this as a measure of what's happening in the ocean is a really important tool. And so the Antarctic Peninsula is an area that has undergone really a lot of climate change in the past 50 years. So that is the Antarctic Peninsula, and the study site where these birds are breeding this is like a blown up picture, is right there on the South Shetland Islands, which is just a little bit north of the peninsula. There's been really marked reductions in sea ice cover and lately, which has been linked to krill availability. Krill are really important. They're like the key, one of the key species in the entire marine food web. They're super abundant. They're eaten by everything. And so when sea ice declines and then krill decline because they rely on the sea ice, it can cause really severe trophic cascades. And so there are also fish that eat sea ice, or they don't. Fish don't eat sea ice. Fish eat krill, and therefore the fish populations are also linked to sea ice. So my hypothesis is that low reproductive success of these skuas occurs when they're consuming smaller and younger fish, and that they're consuming smaller and younger fish when sea ice is low. To do this, I used otoliths, which are ear bones of fish. These are really awesome. They don't look that awesome, but they're really awesome because they're like 2 millimeters, but they're calcium carbonate, so they don't get digested. So and they can be kind of excreted in guano samples, and then guano samples get sent to me, and I sort through them. Guano is bird poop. And I find all of these little ear bones. They're species specific, so you can identify what species of fish they've been eating. And then also, these otoliths grow with the fish, and so you can measure the otolith and figure out how big the fish was, how much the fish weighed. And then, in addition to all of that, they also get these annual bands. And so you can count these bands and tell how old the fish that they're eating are, all from this little 2 millimeter stone. The fish use them for balance and buoyancy, but we don't really care about that. We like them because they tell us things. And so I sorted through all of these samples from King George Island, isolated all of the otoliths, measured them, identified them, and then a subset of those I was able to age over the summer with the help of Andrea. So I found that these birds were really only consuming 2 species of fish in all 7 years. Electrona antarctica, which is a pictophid, it's the Antarctic lanternfish, and Plerogramma antarctica, which is a notothenid, the Antarctic silverfish. And then there are 9 other species that are in these little blue bars at the top. So really only 2 species. So a little bit more about these species. Both of these are major krill predators. They pretty much only eat krill, and they're really ice dependent, not only because of the krill, but they also spawn under sea ice, use the sea ice as like nursery grounds, as protection. And so when sea ice declines, these fish are really affected, both because their main diet, their main food source is decreased, but also because they lose a lot of suitable substrate and habitat that they rely on. And so the reproductive success of the skuas throughout these seasons really obviously dropped a lot in these 2 years. These birds are really long-lived. They've been monitored since the 70s, and this is the first drop like this that they've seen since the 70s. And so I really just wanted to get at why? What happened these 2 years? Which leads back to my hypothesis. I thought that it's because changes in sea ice change their fish prey. And so I looked at the sizes of the 2 main species of fish they were eating, Electrona and Plerogramma, and I found that, so these are the 2 years when reproductive success dropped. And in the year before, and then those 2 years, Plerogramma were significantly smaller than they had been. And then in these 2 years, when reproductive success recovered, so did the size of Plerogramma, which is pretty, it almost mirrors exactly the same trend, which is exciting. The sizes of Electrona didn't really seem to relate all that much, but I think it's also important to point out that the Plerogramma were also significantly larger than Electrona, and so the fact that the larger of the 2 species of fish is the one that shows these trends, I think is interesting. So I also wanted to look at the ages of the fish that they were eating. So I aged a subset of each species of fish from each year. And from the ones that I aged, I would try to see if I could use the size of the otolith as a proxy for age, because they're not easy to age. And I found that actually for both of them, they are very significantly correlated, but especially for Plerogramma, this correlation is really strong. And so the Electronas didn't show much of a relationship. They're also easier to age than the Plerogramma, and so the fact that the species of fish that seems to be most related to trends in reproductive success, that are harder to age, the fact that this relationship is so strong and so significant is really promising, because it means that I don't have to go and age all of them. But it also means that I can conclude that when they're eating larger fish, they're eating older fish, and when they're eating smaller fish, they're eating younger fish. And so, they consume these 2 main species of fish, and the reproductive success of the birds really appears to be linked with Plerogramma antarctica consumption. And based on my regressions, I can conclude that that the size and the age of these fish are important, because when they're eating smaller fish, they're also eating younger fish, which in the future we can do, like looking at actual sea ice data, try to track the trends in these fishes, the breeding of these fish, and see if we can tell how old these fish are, we can trace it back and figure out what years there was low sea ice and see if that correlates to the actual ages of the fish. And so, but also otoliths can be used as an indicator of the diets of these birds. They don't necessarily represent total diet. But this is really promising because, I mean, climate change is really impacting marine food webs, and the fact that we can use the reproductive success of these birds and found this link between the reproductive success of these birds and the sizes and ages of these fish means that we can use these birds as an indicator of at least some marine species, which is really powerful just because of the difficulty of sampling in marine environments. And as climate change continues to happen, and continues to get worse, being able to establish marine indicators that are terrestrial, that can be seen, that are abundant, conspicuous, is exciting. But there are still a lot of questions that I want to ask and answer. I really want to look at the sea ice data, try to, because right now I've found a link between the fish and the reproductive success, but I'm hoping by looking at sea ice data, I can link sea ice data to reproductive success through these fish, which is eventually what I want to get at. Thank you to everyone who has helped with everything.
Maybe in the second, it was the chlorogramma, there was a dip in the population in 07 and 08. Yeah, I guess 07 to 09.
This is the size. Sorry.
I mean, a dip in the size. Does that correlate with anything?
Yeah, with these 2 years.
Well, yeah, with the reproductive, but I mean, is there any, you know, like, I guess what you're saying is there, it's another study to look
Yeah.
at sea ice or climate variations.
Yeah, I mean, I would hypothesize that either very recently before that or in those 2 years there was low sea ice, which, I mean, if I don't know that, but that's what I think is related to it, and so that's what I want to continue to look at.
Maybe, do you know if these skuas feed their babies with their fish, or they just, how do they take care of it? Why is the reproductive success low? Because there's no fish to feed the babies, or because the skuas are themselves starving?
I think probably both. I mean, so this graph doesn't actually have, there are 3 measures of reproductive success that were measured. This is just the ultimate, like, number of fledglings that left, but they also, the eggs that were laid and the chicks that hatched were also measured. And in 2008, 2009, the amount of eggs that were laid actually went up, like back to normal. And part of something that I was thinking was that it could be that they're also migratory. So it could be that the adults like left and came back to the Antarctic Peninsula and had gotten enough food throughout the year that they came back and were in good enough condition to lay eggs, but then there still wasn't enough food there for them to maintain their condition and actually have the eggs hatch and have chicks fledge. And so I think that it is a combination of adult condition and food available for adults and also what they're able to feed their chicks. Yeah.
So the skua